this is a bit of cool integration I did the other day. Hope you like it. Right, so what we're kind of trying to do here is find the value of two intervals, I1 and I2, which are, I1 is cos x over sin x plus cos x integrated with respect to x. I2 is sin x over sin x plus cos x integrated with respect to x. What we're trying to do is find out what these integrals actually evaluate to. On their own, they look pretty hard. Using your standard techniques you might get at A level. They're, I wouldn't know how to begin to tackle them. However, there's a quite nice way of solving them without doing anything that really feels like integrating. The place I got this question from was Dr. STC Siklos' booklet, Advanced Problems in Mathematics, which is kind of prep for the STEP paper, which is admissions for getting into a couple of top universities for maths. It's quite a nice question generally. I think that's what the papers are about. So anyway, the question was, the first part of the question, given these two, and evaluate by considering I1 plus I2 and I1 minus I2. So that's the first hint you need to see how to proceed. So first of all, what's I1 plus I2? So I1 plus I2. Grab a pen. I1 plus I2 equals integral of cos x over 2. Okay, new ink cartridge for the win. As I was saying, I1 plus I2 equals cos x over sin x plus cos x plus dx plus the integral of sin x over sin x plus cos x with respect to x. Yeah, I mean, I'm not saying anything controversial there. That's what we define them as. Yeah. Now, basic rule of integral is the integral of 1 f of x plus the integral of g of x is the same as the integral of f of x plus g of x. So we can add these together. So this ends up being the integral of, and these are the same denominator. So we can say sin x plus cos x over sin x plus cos x dx. However, here we have a fraction with the top the same as the bottom, so it's 1. So this actually is equals dx, which equals x. So we can say that I1 plus I2 equals x, which is quite cool. Right, computer's just eaten my last 2 attempts to do this. It's rather irritating, so let's do this again. I1 minus I2 equals cos x minus sin x over sin x plus cos x integrated with respect to x. Why? Similar reasons to why that is that. Not too difficult. And then this integrates to ln abs sin x plus cos x. Why? That is the derivative of that, and so if you were to derive this, you get that. An integration is defined as essentially the reverse of differentiation in this case. And so I1 plus I2 equals x, as we found earlier. We now have 2 equations in I1 and I2. If we add them together, they equal 2I1, and they also equal x plus ln sin x plus cos x. We've got rid of the I2, so if we just divide this by half, we get I1 equal to half x plus ln sin x plus cos x. So we've evaluated the integral. Similarly, I2 equals to half x minus ln sin x plus cos x. So we've evaluated these 2 integrals just doing this bit of integration and this bit of integration. Nothing else. And a bit of simultaneous equations and the hint we got at the beginning. which is rather cool. Final challenge. If we have I3 equals cos x over a cos x plus b sin x, where a and b are constants, can you evaluate that using a different a similar method? Have a go.